This entire section covers just two concepts, which are really similar concepts. And the concepts or the topics for this section are subsets and proper subsets. This is another video that I'm re-recording because I didn't like the way the first video came out. And the first attempt at this might have been the very worst lecture I've given, maybe ever, but in a really long time. Anyways, each one of these words is going to relate to a symbol. Symbol will have a definition, and we'll do problems just to help us understand the definition and what the term is. So the first of the two terms that we'll talk about is subset as opposed to proper subset. And the symbol for the word subset, it's kind of a U on its side with a line under it, and this line we could almost think of an equal. This symbol I could almost think of as a less than or equal to in some sense. In a bit, we're going to worry about the second term, which is proper subset. And the symbol that we'll use when we're talking about proper subset is just kind of the U on its side without the line under it, or kind of the equal part. So first thing I need to do is define what a subset is. And a subset compares two sets. So when we use the word subset or proper subsets, we're very specifically comparing one set to another set. So we're comparing two sets. And we can say one set A is a subset of another set B, given the symbol A is a subset of B, if and only if all the elements of A are also elements of B. And then I said using this subset symbol in a problem allows the two sets to be identical or equal. Well, let me formalize this a little bit better, then do some examples. So to be for set A to be a subset of set B, we need two criteria. For A to be a subset of B, A has to be a set. A can't be a subset if it isn't a set. And second, every element X in A is also an element in B. So if A is a set and every element inside A is also an element contained in B, then A is a subset of B. This may not make any sense. It makes sense to me just because I read mathematics well. So let me do some examples to help you understand what it means to be a subset of another set and what it means not to be a subset of another set through a couple examples. So here's an example where I give you two sets. I give you the set A, which contains the letters A, B, C, and D, and the set B that contains the letter A and B. And the question is A a subset of B? So this is asking, is A a subset of B? And for A to be a subset of B, it needs to satisfy two criteria. The first criteria, A has to be a set, and it's real easy to be a set. If you're in set braces, you're a set. So A is a set, so it satisfies the first of the two criteria for A to be a subset of B. The second criteria means every element in A is also an element in B. Unfortunately, the second one is going to be not satisfied, because if I look at the set A, which has the letters A, B, C, and D, for A to be a subset of B, every element in A, or every letter in A, would have to also be in B, but B is missing the C and the D. For A to be a subset of B, somewheres in B, you need the letters A, B, C, and D. B could have more than A, B, C, and D, but at least has to have A, B, C, and D. Because there are two elements, namely the C and the D, that are in A that are not in B, that means the second criteria isn't satisfied, that every element inside set A, B, and C, and D also needs to be an element inside set B. So if all four letters A, B, C, and D were in B, then A would be a subset of B. But since C and D are in A and they're not in B, both rules are not satisfied, and we can say A is not a subset of B. If I'm answering the question, is A a subset of B, might just answer no. I'll just do yes if it is a subset, no if it isn't a subset. On the next page, I switch up the letters because the letters don't always have to be A and B. And I give you two sets. I give you a set for S, which has the numbers 1, 2, and 3, and a set for T, which has the numbers 1, 2, 3, and 4. And I ask the same question. Is S a subset of T? Well, what does it mean for S to be a subset of T? It means it needs to satisfy two rules. The first rule is S needs to be a set. S is a set because it's in set braces. As long as I see the elements inside set braces, that qualifies to be a set. The second thing I need, the second rule, is that every element in set S is also an element in set T. Well, let's look at the elements of set S. There's a 1 in S. There's also a 1 in T. There's a 2 in S. There's also a 2 in T. There's a 3 in S. There's also a 3 in T. So every element in set S is also contained in set T. Set T has an extra element in it that's not part of set S, but that's not a big deal. Just as long as any element in set S is also in set T, and that means criteria 2 is satisfied. So S is a set, and every element in S is also in set T. So S is definitely a subset of T. So my answer to the question, is S a subset of T? I'm just going to say yes. Switch this one up a little bit too. I'm using the same letters, but I reversed the T and the S. I'm asking the same sort of question. Given these sets, is T a subset of S? So is the set T, which equals the set containing the letters A, B, a subset of S, which contains the letters A, B, C, and D? This is what I'm asking, is if this set AB is a subset of the set A, B, C, D, because T is equal to AB, S is equal to A, B, C, D. So let's figure out if it is or not by looking at the two rules. The first rule, T has to be a set. T is a set because it's in set braces, so we satisfy the first rule. Second rule, every element in T has to be in S. Well, let me look at the elements of T. The first element of T is A. It's an S. The second element of T is B. It's also an S. There are a few other elements of S that are kind of extra letters, but those don't matter. The two letters in T are also in A, so the second statement is satisfied. And so because both rules are satisfied, we can say yes, T is a subset of S. Let's do another one where I give you and ask you the question, is C a subset of D? And what I'm asking here is this C, the set containing 1, 2, 3, a subset of the set containing 3, 1, 2? If I want to write this without the letters C and D, I'm asking, is the set C, which is equivalent to the set containing the numbers 1, 2, and 3, is that a subset of the set containing 3, 1, and 2, which is the representation of D without the letter D? So let me see if the two rules are satisfied. If the two rules are satisfied, the answer is yes. The first rule is C has to be a set. Because C's in set braces, it's a set, so it satisfies the first rule. Now let me see if every element in C is also in D to check on the second rule. So the elements of C are 1. 1 is in C. It's also in D. The second element of C is 2. 2 is in C. It's also in D. The third element of C is 3. 3 is in C. It's also in D. Because every element of C is also an element of D, row 2 is satisfied. And the answer is going to be yes. Is C a subset of D? Yes, because it satisfies the two criteria. Not sure why I took the time to write this. I wasn't asked this, but it's also true that D is a subset of C. You can do that if you care to show that, but I'm not going to show that. So I have another sneaky example. And I ask the question, is A a subset of B, given A is the numbers 1 and 2, and B is the set containing the numbers 1, 2, and 3. So in order for A to be a subset of B, A has to satisfy two criteria. The first criteria is A has to be a set, and this is sneaky. Because the A isn't written in set braces, A is not a set. So the first rule is violated, because in order to be a subset, the set A, or the first letter that's written, has to represent a set. Because A doesn't represent a set, rule 1 is violated, or it's not satisfied. So I can stop checking. Once one of the rules is violated, this answer to this question is no. So here, A is not a subset of B. So that's the first of the two definitions that we have in this section. So the first definition is subset, given that symbol. And the second definition that we're going to go into next is proper subset, given this symbol without the equal sign. And subsets and proper subsets are similar. There's just one slight difference between subsets and proper subsets that make them different, and that's what we'll talk about. So now we'll move on to proper subsets. And we say, again, when you're talking about subsets, we're comparing two sets. Here, I'll say set A is a proper subset of B using the proper subset symbol as opposed to the subset symbol. The subset symbol is that. The proper subset symbol is that without the line. And we say A is a proper subset of B, symbolized by A is a proper set of B, if and only if three conditions hold. The same two conditions that I had for subsets. A has to be a set. Every element of A is also an element of B. And we have a third rule that A can't equal B. So for this definition of subset, it's okay for the sets to be equal. But for the definition of proper subset, it is not okay for the sets to be equal. That's why we remove that line. That line I think of as an equal sign. So let me just do some examples so we can see whether two sets are proper subsets by just checking the three rules. So first example, is A a proper subset of B? So this case, I'm checking proper subsets. And proper subsets have to satisfy three rules to be true. So I'm giving you two sets. A, the set containing 1, 2, and 3. B, the set containing 1, 2, 3, and 4. And I want to see if the set A, which is represented by the set 1, 2, 3, if that's a proper subset of the set B, which is the set containing 1, 2, 3, and 4. So to see if this is a true statement, if A is a subset of B, I just have to satisfy the three rules. The first rule is set A has to be a set, and A is a set because it's written in set braces. So the first rule is satisfied. The second rule is every element in set A also has to be an element of set B. Well, let me look. For trying to satisfy the second rule, 1 is in A, 1 is also in B. 2 is in A, 2 is also in B. 3 is in A, 3 is also in B. So the three elements of A are also in B, so rule 2 is satisfied. The next thing is the sets can't be equal. So third, the sets can't be equal, and these sets aren't equal. So the sets are not equal because for the sets to be equal, they have to have exactly the same elements, and the second set has a 4 that the first doesn't. So the third rule is satisfied that the sets aren't equal. So all three rules are satisfied, so A is a proper subset of B. And my answer to the question is A is proper subset of B is going to be yes. Let's do it with these two sets. So I'm asking the question, is S a subset of T? My answer is either going to be yes or no. S is the set represented by the letters A, B, C, and D. And T is a set represented by the letters A and B. So I'm trying to see if this is a true statement. Is the set A, B, C, D, which is what S is equal to, is that a proper subset of the set T, which is the set containing A and B? So I have to check the three rules. First rule, S has to be a set. Because S is in set braces, it's a set. Second, every element of S has to be an element in T. So for the second rule, A is in S, A is in T, that's good. B is in S, B is in T, that's good. But neither C nor D that are in S are in T. So I'm blown up and violated the second rule, because the second rule says any element in the left set has to also be an element in the right set. Well, there's two elements in the left set that aren't in the right set. So rule 2, the second thing that I need to satisfy isn't satisfied, so I'm done. Once one of the three rules or one of the three criteria are violated, my answer to the question is going to be no. S is not a proper subset of C because all the rules aren't satisfied. S is not a proper subset of T, and I'm just going to say no for my answer. All right, so let's see it this way. Is T a proper subset of S? So for these two sets, is T a proper subset of S? What I'm trying to take and satisfy to see if T, which is the set AB, is a proper subset of the set S, which is a set containing A, B, C, and D. In order for the set T to be a proper subset of S, I need to satisfy three criteria. The first criteria, T needs to be a set. T is a set because it's in set braces, so the first criteria is satisfied. Now I'll move on to the second criteria, that every element in T has to be an element in S. So the first element of T is A, it's also in S. The second element of T is B, it's also in S. Every element of T, which is A and B, is also in S, so the second criteria is satisfied. Now I'll move on to the third criteria. The third criteria says the sets aren't equal, and these sets aren't equal because S is bigger. It has a couple extra letters. So the third rule is satisfied that the sets aren't equal. Because all three rules are satisfied, it's the case that T is a proper subset of S. So my answer to this question is just going to be yes. Is T a proper subset of S? The answer is yes. Let me move on to do another example. Is C a proper subset of D, where C is the set containing the numbers 1, 2, and 3, and D is the set containing the numbers 3, 1, and 2. So the question that this is asking me to answer, is C a proper subset of D, is this question. Is the set containing the numbers 1, 2, 3 a proper subset of the set containing 3, 1, and 2? So I do that. It looks like C and C, that's subset there. I look at the rules. First rule, C is a set because it's in set braces, so the first rule is satisfied. Second rule, every element of C is also in D. Well, the three elements in C, 1 is in C, it's also in D. 2 is in C, it's also in D. 3 is in C, it's also in D. So every element in C is also in D, so it satisfies the second rule. The third rule says the sets can't be equal. Unfortunately, these sets are equal because they have exactly the same three elements. So the third rule isn't satisfied because this symbol doesn't allow the sets to be equal. So the big difference between the subset symbol and the proper subset symbol the subset symbol allows the sets to be equal, whereas the proper subset symbol does not allow the sets to be equal. It has that third rule. Whereas for the subset, we just need the left set to be a set and every element in the left set to be contained in the right set. The proper subset blows up if the sets are equal. Let's do one more example here. Is A a proper subset of B given A is the numbers 1 and 2 and B is the set containing the numbers 1, 2, and 3. So to see if A is a proper subset of B, I got to satisfy each of the three criterias. The first criteria is A has to be a set, and that's violated here because A is not a set. Once one of the rules is violated, I don't have to check the additional rules because A isn't a set, it can't be a proper subset. So my answer to this question is going to be no. The next couple pages I have talk about empty sets, and I don't ask anything about the empty sets and subsets. I'm going to skip over those. If I feel the urge to come back to it, I'll come back to it, but let's not worry about empty sets with subsets right now. All right, so we're just about ready to get into some homework, so let's do that. I'll start flashing some homework on and we'll just see what we can do with it. So problems 1 through 18, we're going to answer yes or no. And then it says, if no, give a reason. Let me model what I want here. So problem 2 says, is A a subset of B, where A is the word Phoenix and B is the set containing, I'm going to abbreviate here, Phoenix, Glendale, Peoria, I'm out of room, Scottsdale. So in order for me to answer yes, I need to satisfy two criteria. The first criteria is A needs to be a set. And this is the big no because the A doesn't have the set braces. So my answer to this problem is going to be no. And the reason is because A is not a set. For your problem 1, I think it's going to be essentially exactly the same thing. I believe you're going to say no as well. And it's going to be the same reason because it's not a set. So my answer and your answer should be essentially the same. So if your answer for number 1, I think it's the same sort of deal. You'll probably say no, A is not a set. So move on to 3 and 4. So is C a subset of D? I will do 4. So what 4 is asking me is the set that contains the word silver, which is my C, is that a subset of the set containing gold, silver, and diamond? And I need two criteria. First, the item on the left needs to be a set, and C is a set because of the set braces. And 2, it has to be contained, meaning every element in the left set has to be contained in the right set. Because C is a set and the only element in it is in the right set, my answer is going to be yes, C is a subset of D. Similarly, when you go to do, it's going to be yes, and you're not going to need to state any reasons when your answer is yes. Had a hiccup in my video. Hopefully it's understandable. So I'll just keep moving on. If something's bad there, let me know. All right. Well, let me do your 5 with you as opposed to doing 6 because I don't think that it's they're comparable. So for problem 5, is A a subset of B, which is really asking, is the set containing the numbers 2 and 3 a subset of the set containing the numbers 1, 2, 3, 4, and 5. And I just need to satisfy two criteria. First of all, the left item needs to be a set. It's in set braces, so it's a set. The second item is every element in the left set needs to be contained in the right set. There's two elements in the left set, 2 and 3, and every element in the left set is also element in the right set, so that's satisfied. So my answer to number 5, or your number 5, is going to be yes. Both 7 and 8 are a little bit tricky. I'll let you work on 7. I'll tell you what your answer should be in a bit. For my problem 8, is A a subset of B given A is the set containing the letter A, and B is the set of all X such that X is a vowel? That's written in set builder notation. That doesn't help me. I'm going to rewrite set B in roster form. And set B, I'm going to say it's a set A, E, I, O, and U. I don't usually consider Y a vowel, but I guess I could put it in the set and it wouldn't change the answer to my question. So question 8 is asking me, is set A a subset of set B, where set A contains the letter A, and set B contains the letters A, E, I, O, and U. And when I go to do this, rule 1, A needs to be a set, and that's satisfied because of the set braces. Rule 2, every element in A needs to be contained in B, and the only element of A is A, and that's also in B, whether you do or don't include the Y. This is going to be satisfied, so my answer is going to be yes. When you do your number 2, your answer is going to be no, and the reason is because this part right here isn't a set. Oh, I do have an empty set one. Let's skip for what it's worth. Let's just skip 9 to 12. It turns out that the empty set is a subset of every set. These answers would be yes. I just don't think this is that important. I don't ask it on the test, and I didn't remember asking it in the section, so sorry about that. So let's just skip over those and move on and skip all the way down to 13. So we're skipping 9, 10, 11, and 12 because they talk about proper subsets, and it's just not that. I mean, they talk about empty sets and subsets, and that's just not that important unless you are getting into some real theoretical math, which we're not. So next two problems talk about proper subsets, and the rules for proper subsets are 3. So for question 14, it's asking, is A a proper subset of B, where A is the set containing A, B, C, and D, and B, so this is for number 14, is the set containing D, C, B, and A. For this, I need 3 criteria. I need the left set to be a set, I need it to be contained, and they can't be equal. So the first rule is satisfied because A is in set braces, it's a set. The second rule says every element in A needs to be an element of B. Well, the 4 elements in A is in A, it's in B. B is in A, B is also in B. C is in A, C is also in B. D is in A, D is also in B. It's also contained because every element of A is also in B. Here's where we break down because proper subsets don't allow the sets to be equal. And so my answer is going to be no, because the sets can't be equal. So the reason I have to say no is because the sets are equal and the proper subset symbol doesn't allow the sets to be equal. That's my answer to 14. It's also going to be your answer to 13. 13 will have the same answer as this, because it's essentially I've given you 2 equal sets again. I guess I could do, well, I crossed it out. Let me do 15 with you. So 15 is asking, is C a proper subset of D, where C is the set containing 1, 2, 3, 4, and 5, and D is the set containing 1, 2, 3, and 4. So I need to verify 3 criterias. I need to be a set, I need to be contained, and I can't be equal. Any one of those 3 is violated, I'm going to say no, and I'm going to include the reason why in my answer. So first, C is a set because it's in set braces. And then the second one, this is where I'm going to break down. Every element in C needs to be an element of D for it to be contained. Well, there's 5 elements in C, and one of them is a 5, and that 5 is in C that's not in D. So C is not contained in D. So my answer for 15, I can just say no. And then for a reason, I might say 5 is not contained in D, because every element in C needs to be an element of D, and I found an element of C that wasn't in D. That's why I need to say no. All right, one more, then I think I'll break this into a part 2. So for 17 and 18, we're given sets A and B, and we're asked to see if they're proper subsets. So for 18, is A a proper subset of B given A is a set containing E, B, C, D, and A, and B is a set containing A, B, C, D, E, and F. So let me see. I need 3 criteria for a proper subset. I need to be a set, I need to be contained, and I can't be equal. Set is easy because A is in set braces. I satisfy the set part of this. And how about the contained? So let me go. E is in A, E is in there, that's good. B is in A, B is contained in B. C is in A, C is contained in B. D is in A, D is contained in B. A is in A is contained in B. So every element in A is also an element of B, so containment works perfectly. Now the sets can't be equal. Well, the sets aren't equal because B has this extra F. So my answer to problem 18 is going to be yes. Similarly, your answer to problem 17 should be yes. So let's stop there and break this video into 2 parts just so you don't get overloaded and you can look at the next part maybe when you're fresher than you might be right now.